What's up, everybody? This is Tech G back with another video. And in this video, we're going to be talking about AI performance metrics. So let's get into it. Let's say you just trained a fancy new AI model. Maybe it's a spam detector, a medical diagnostic tool, or a system that predicts which customers are likely to cancel their subscriptions. You spend hours fine tuning the algorithm and feeding it data. Now you're staring at a number on your screen like 93% accuracy. Well, that sounds impressive, right? Well, maybe. So here's the catch. That number doesn't tell the whole story. Evaluating an AI model isn't as simple as checking a single score. To really understand how well a model is doing and where it might be failing, you need to dig deeper into a few key metrics such as accuracy, precision, recall, the F1 score, and the confusion matrix. So in this video, I'm going to unpack each of these metrics in plain English. You don't need any type of mathematics degrees to understand this. This is just going to be real talk with relatable examples. So let's go ahead and get into it. All right, so the first thing we need to figure out is exactly why do metrics matter? So imagine you're building a robot dog that's supposed to bark every time someone tries to break into your house. You test it and it barks every time the mailman comes, but not when a burglar actually sneaks in. Technically, the robot is working, but it's doing the wrong thing really well. And this is why performance metrics matter. They help us figure out, is the model making the right predictions? How often is it wrong? What kind of mistakes it's making? And is it balanced or biased? So let's go ahead and break down these tools that you can use to evaluate a model to make sure it's doing what it's supposed to do. Before we get into specific metrics, let's start with the confusion matrix because it's the foundation for understanding everything else. So exactly what is this thing? Well, the confusion matrix, this is a table that shows how many times your model made correct and incorrect predictions. It's especially useful for binary classifications like yes or no predictions. So let's say that you're building a spam filter. You feed it a bunch of emails and it classifies each as either spam or not spam. Well, here's what a confusion matrix actually looks like right here on your screen. So let's go ahead and define these terms in simple language. So you have what is called a true positive. Now, as this relates to spam, that means that this is spam that was correctly labeled as spam. You have what is called a true negative. This is legit email that was correctly labeled as not spam. You have what is called a false positive. This is a legit email that got wrongly flagged as spam. Then you have what's called a false negative. This is spam that the model missed and labeled as not spam. So these four values, they help you calculate every other metric that we're going to talk about. All right, so our first metric is called accuracy. So accuracy, this is the simplest and most well-known metric. It tells you how often your model got things right. And as you can see on your screen right there, the formula is accuracy equals all of that stuff that comes after it. But in plain English, this simply states out of all the predictions that your model made, what percentage were correct? So here's an example of how all this works. Let's say that your model analyzed 100 emails and 90 of those emails were correctly predicted, where it stated 80 of them were not spam and 10 were spam. And then it stated 10 of them were incorrectly predicted. Well, based on those numbers, you would have an accuracy rate of 90%. Now, when exactly is this useful? So accuracy is great when your data is balanced, meaning you have roughly equal amounts of both classes, like spam and not spam. Now, when is it misleading? Well, let's say only 5% of emails in your data set are spam. If your model predicts not spam for every email, it'll be right 95% of the time, but it's useless at catching spam. So the moral of the story is accuracy alone does not always tell the truth. All right, our next metric is precision. So precision, this tells you how many of the positive predictions were actually correct. And as you can see, there's the formula on your screen right there. And basically what this formula is saying is that of all the times the model said that this is spam, how often was it right? So here's an example to help drive it home. Let's say your model says 15 emails are spam. 10 are actually spam, which would be a true positive. And then 5 are legit emails that got flagged wrongly. That'll be a false positive. So your precision, once you do the calculations, that'll get you 67%. So why does this matter? Well, precision is super important when false positives are a big problem. So to put this into another example, let's think about medical diagnosis. So let's say an AI predicts whether someone has cancer. A false positive, this can cause anxiety, extra tests, and unnecessary treatment. Precision, this helps you minimize those false alarms. So if your goal is to avoid crying wolf, then focus on precision. Our next metric is called recall. So, exactly what is this? Well, recall, which is also known as sensitivity or true positive rate, this tells you how many of the actual positive cases your model caught. So, once again, you can see the formula on the screen. And to put that in plain English, that basically states out of all the spam emails that exist, how many did your model find? So, here's an example. You have 20 emails that are actually spam. Your model correctly identifies 15 of them. That will be a true positive. However, it misses 5. That'll be a false negative. So if you do the formula, you would have a recall of 75%. So why does this matter? Well, recall is crucial when missing a positive case is dangerous. So let's put that into a real world application like fraud detection. So if a fraud detection system misses fraudulent activity or false negatives, that's money out of the door. You want to catch every shady transaction, even if you occasionally flag a legit one. So if your goal is to catch every possible true case, even if you get a few wrong, then you want to focus on recall. And then we have our fourth metric, which is called the F1 score. And this is the harmonic mean of precision and recall. It balances the two, especially when you want a single number to judge overall performance. So on your screen, you can see the formula. And basically, you could think of this as a referee between precision and recall. So here's an example. Let's say your model has a precision of 0.08, and then you have a recall of 0.06. Then once you do the calculations, your F1 score come out to be 68.5%. So exactly why does this matter? Well, the F1 score, this is a great all-around metric when your data is imbalanced and you care about precision and recall, and you need a single number to compare models. So if you're building something like a resume filter or a content moderation system, the F1 scores, they help you tune that balance. And right here on your screen is a quick cheat sheet explaining each metric and the different purposes that they serve. So if you find yourself in the business of building AI models, you want to pick the best one depending upon the type of problem that you're trying to solve. All right, so let's go over a real life scenario, and we're going to go back to our email spam filter example. So let's say you run a model on 1,000 emails, and out of the 1,000 emails, you have 700 legit emails are not spam, and then you have 300 spam emails. And when it comes to your model predictions, your model predicted 250 spam emails that were correctly flagged. That'll be a true positive. It also predicted 50 spam emails that were missed. That will be a false negative. It also predicted 100 legit emails that were incorrectly flagged as spam. That'll be a false positive. And then you have 600 legit emails that were correctly identified. That will be a true negative. And once you go through and do all of your calculations, you'll see that your accuracy rate was 85%, your precision rate was 71.4%, your recall rate was 83.3%, and your F1 score was 76.8%. So basically, when it comes to all of this, you get a full performance picture and not just a flashy 85% accuracy headline that you could use to sell your email spam filter product. All right, so let's go ahead and wrap all this up. So AI models, they can be flashy, but if you don't know how to evaluate them, then you're flying blind. So here's a quick takeaway checklist. A confusion matrix. This is where you want to start because you'll be understanding how many predictions are true or false or positive and negative. Then you have accuracy. This is good for balanced data sets, but you don't want to trust it blindly. Then you have precision. This is best when false positives are costly or dangerous. You have recall, and the focus here is when missing true cases is the worst case scenario. And then you have what is called the F1 score, and this is the go-to metric when you need balance. So remember, no single metric tells the whole story. You want to use them together to get a clear, honest picture of how your model is really performing. Now that we got through all that, let's do some check on learning. So our first question is, which metric is the most useful when dealing with a class imbalance problem, such as you having many more negatives than positives? Would this be accuracy, precision, recall, or the F1 score? And the correct answer is this will be an F1 score. So accuracy, this could be misleading with imbalanced data sets because a model could predict the majority class and still achieve high accuracy. Precision and recall, they focus on different aspects of performance, but F1 score balances both precision and recall, making it a better metric for imbalanced data sets. Next question. A spam detection model identifies 80 spam emails correctly, but falsely marks 20 legitimate emails as spam. Which metric measures how well the model avoided labeling legitimate emails as spam? Would this be recall, accuracy, precision, or the F1 score? And the correct answer is this would be precision. So, precision, this measures the proportion of true positives or correctly identified spam emails out of all predicted positives or emails that are labeled as spam. It tells us how many of the emails marked as spam are actually spam, which is critical when minimizing false positives like legitimate emails that are wrongly classified as spam. And our final question: what does the true negative value in a confusion matrix represent? Is it the model correctly predicted the positive class? Is it the model incorrectly predicted the positive class? Is it the model correctly predicted the negative class? Or is it the model incorrectly predicted the negative class? And the correct answer is the model correctly predicted the negative class. So, in a confusion matrix, a true negative is when the model correctly identifies a negative class as negative. So, for example, it correctly recognizes that a normal email is not spam.